myself, Virinder, Physics faculty. Today topic of discussion is Gauss law. This law is also commonly known as Gauss theorem. Is the same. Actually, this law was proposed by scientist Louis in 1773 and later on this law was formulated by Carl Gauss in 1830. What is this law? This law actually, this law actually a relationship between electric field and electric flux. Understood? This is a little bit introduction about the Gauss law, we can say Gauss theorem, because this law was formulated by the Carl Gauss. That's why this law is named as Gauss law or Gauss theorem. This law from 1773 till today, this law was experimentally verified by the various scientists. Now, what is Gauss law? I am going to tell you the statement given by the Gauss that was literally known as Gauss law. First, I am going to rub this thing. Statement of Gauss law. Statement of Gauss law. Before delivering the statement, I want to make you understand the concept of the Gauss law. After that, you will easily understand the statement. Then there will be no any need to craft the statement. You will easily understand. Okay? First of all, I want to make you understand the concept, the real concept or the practical concept of the Gauss law. That is, we have a charge Q, point charge Q, and we all are well familiar with this thing that we have mainly two types of charges. One is positive and second one is a negative. There is also a concept of electric field lines. If there is a positive charge, it emits the electric field lines like this way. And if there is a negative charge, the electric field lines will come towards it from the infinity point. Infinity means where the potential is 0. Understood? And if we enclose this charge in a closed surface, let us, for the better understanding, I am going to draw another diagram. Let we have a closed surface, and here the charge Q. Understood? And it will emit the electric field lines in this way. Okay? And you are also known about the concept of electric flux. That is dot product of electric field and area vector. It is the number of electric field lines crossing per unit area perpendicular. And if you want to find out the electric flux of this closed surface, if you want to find out the electric flux of this closed surface, then you can use this formula. Okay. I usually say in my teaching that we should do the small work initially. After that, we should do the large work. If we want to find out the total electric flux of this closed surface, I mean that the total number of electric field lines coming out of this closed surface. If I want to find out this, then I can use this formula. Okay. Firstly, before finding the total flux of the total closed surface area, firstly I will consider a small surface area. Let it is ds. And this is the area vector n cap. Is it okay? Here is the charge Q. Let we place a unit coulomb charge here. Positive repel, the electric field will be in this direction. Here the direction of E and ds is same, and the electric flux through this small area shaded region d phi will be equal to E dot ds for this small shaded region. And if I want to find out the electric flux of the total surface area of this closed surface, then I can divide the closed surface area into infinite number of small area elements like ds. And if I want to find out the total flux of the total area, then I will sum up the all flux d phi through the all small area element ds. For the total flux, I will do the integration of d phi. Integration means I am making the sum of all flux of d phi through all small area elements ds. Because this surface is closed, therefore I will use a symbol here, this. This is known as the closed integration of d phi. Here, closed integration of E dot ds. Understood? Now, electric flux through the complete closed surface area is closed integration of E dot ds. This is the mathematical formula to find out the electric flux through this closed surface area. This is a mathematical formula. But according to Gauss law, there is no need to do the lengthy calculation. We can find out the electric flux of the closed surface area in a just single step. According to Gauss, the total electric flux through the total surface area of this closed surface will be equal to 1 by epsilon naught times the total charge enclosed by closed area. Understood? I am saying that according to Gauss, the total flux will be equal to 1 by epsilon naught times 1 by epsilon naught times the total charge enclosed by closed surface. What is the total charge enclosed by closed surface? I mean to say that what is the total charge in the closed surface is Q. Then I will say like here Q. Then electric flux will be equal to Q by epsilon naught. This is Gauss law. We can use the both formulas to find out the electric flux. This and this. This is true, but this is also true. This is Gauss law. This is the mathematical formula we use to find out the electric flux. Thus, we can also write here electric flux is equal to the closed integration of EDS equal to Q by epsilon naught. We can write in this way. Clear? Now we can write the statement. I think I have given you a very better explanation of the Gauss law. After understanding this explanation, there is no need to claim the statement. Now we can write the statement. This law states that electric flux through a closed surface is equal to 1 by epsilon naught times the total charge enclosed by that closed surface, by that closed surface. Is it okay or not? Clear? This is the statement and this is the Gauss law. And we can also write in this way. Okay? Now for the next better understanding, we are moving forward. I am reading this thing. For the main thing which we should consider before applying Gauss law, that is, I am going to write here that if we want to apply the Gauss law, then we will have to consider a closed surface around the given charge. And if there is already closed surface around the given charge, then it's okay. And if there is no any closed surface around the given charge, then we will have to consider it. Okay, we will have to consider it. But it closed surface around the given charge. Without assuming the closed surface around the given charge, we can't apply the Gauss law. Is it okay? Before applying Gauss law, we must consider a closed surface around a given charge, and that closed surface is called Gaussian surface. Is it okay? It doesn't require that closed surface around given charge should be symmetrical or should be asymmetrical. It doesn't matter. Okay? But the surface should be closed. Okay. The closed surface can be symmetrical or asymmetrical. Is it okay? Understood? Now, are we loving this thing? Here, Gauss law phi E electric flux is equal to closed integration of E dot ds is equal to Q by epsilon naught. Here epsilon naught is absolute electric permittivity of free space. Absolute electric permittivity of free space. What it's mean? its being is that. Let's suppose here a charge Q. It is emitting electric lines. But we are here. We are getting the electric lines from here to here. The electric field lines are coming from A to B through this medium. Permittivity means that whether this medium is giving the permission to electric field lines that you can go or you can not go within this medium. It is actually permission. It is actually the permission given by this medium to the electrical lines, that whether they can go through this medium or whether they cannot go through this medium. If the given medium doesn't give permission to electric field lines, or if the given medium doesn't allow the electric field lines, then there will be no any electric field line will cross through the medium, and we will got nothing here. And if this medium is giving permission, is allowing the electric lines, the electric lines will pass through it. Is it okay? This is the permission given by the given medium to the electric lines, that they can pass through that medium. It is equal to 8.854 10 raised to the power minus 12 per Newton per meter square Coulomb square. Is it okay? Now, here is Q. It is a closed surface. These are the this is not a circle, this is a closed surface like a sphere. Okay, electric lines. Here, if the medium is air, then permission is this. And if here the medium is other than air, if medium is other than air, then will the permission to electric lines be same as initial? No, because medium is changed. Different mediums give the different permissions to the electric lines to pass through them. If the medium is other than air, then what will happen? Then permittivity will change. Permittivity will be changed. If the medium is other than air, then electric flux will be equal to Q by epsilon. This is the permittivity of air if the medium is air. This is the permittivity of medium if the medium is other than air. Next, we can further formulate this thing in this way. Q epsilon is the product of epsilon naught and epsilon r. This is the relative electric permittivity. This is relative electric permittivity. Q by epsilon naught and epsilon r can be replaced by K. This is a dielectric constant of the medium. Q by epsilon naught, Q by epsilon naught. This is the flux when the medium was air. We can write as flux when the medium was air. K is the dielectric constant, and this is the flux when the medium is other than air. Now I can write flux in a medium is equal to flux in a air divided by K. Okay, K is the dielectric constant of the given medium. K is a dielectric constant of given medium. Is it okay? Got it? Now I am going to rub this thing. We have drawn the diagram, closed surface, this Q, these are the electric field lines. Okay. This is the enclosed charge, total enclosed charge by the closed surface. What will happen if there are also other charges which are present outside the Gaussian surface, like this way? Let's Q dash, Q double dash. What will happen? Okay, these charges will also produce the electric field. The electric field lines produced by such charges will also pass through this. Okay, let's suppose for the better understanding, I am drawing the one electric field line due to this. Let electric field line produced by this, like this way. Okay, here it is entering, here it is leaving. Understood? Okay. I can write here, for the better understanding, I am just drawing the one electrical line. Here this can be like this way. Okay, one is entering, one is leaving. It means the contribution of flux by this charge is 0, because phi in is equal to phi out. Here phi in is equal to phi out. Okay, there is no contribution to the flux by these outside charges. Contribution to the flux is only due to the enclosed charge. Okay. There is no contribution to electric flux due to external charges. Okay, because their phi in will be equal to phi out, and total flux will be equal to phi in, it will come here, is equal to 0. Contribution to the flux through this surface is only due to enclosed charge. Contribution to flux is only due to enclosed charge, or we can say the interior charges present inside the Gaussian surface. Interior charges present inside Gaussian surface. Okay, I have discussed about the flux. This is a flux. This is a flux. Here is electric field. Done. Now, firstly, I consider in the first case, I consider only this charge. Now, I have two types of charges: interior and the exterior. These charges doesn't make any contribution to flux. The complete flux is only due to this. Okay. Now I am going to discuss about the electric field. Is this case is similar to E? I mean to say that these charges are not contributing to the flux. But these charges are also not contributing to this electric field. No, this is wrong. My second statement is wrong. Okay? Here, it's producing electric field, it is producing electric field. And it is producing electric field. If I find out the electric field at here due to this, that it is E1, and the electric field at this due to this, it will be E2, because this is matter. E1 will be greater and E2 will be lesser, and total electric field due to this charge will be what? E1 minus E2. Okay, E1 is greater than E2. The total electric field due to this charge E1 minus E2, that is non-zero. It means these charges are contributing to the electric field. Okay, now we can say that flux is only due to the interior charges, but this electric field is what? This electric field is the resultant electric field due to all the charges, whether they are present inside or outside. Okay, I am loving this thing. On the left hand side of Gauss law, on the left hand side of above equation, above law, E is actually resultant electric field due to all charges, whether they are interior or exterior charges. Whether they are present inside or whether they are present outside. Okay, now I can hope that you have the excellent understanding about the concept of Gauss law. In the next step, I am going to prove the Gauss law. Phi is equal to Q by epsilon. Okay, my next step is proof of Gauss law. Proof Gauss law. Okay. Gauss law is actually phi is equal to q by epsilon naught. Is it okay? Let's suppose this is a point charge q. This is the closed surface, that is known as the Gaussian surface. I already told you the surface should be closed, whether it needs not to be symmetrical. It can be regular or it can be irregular shape, but should be closed surface. This is the Gaussian surface. Consider a point P here where I want to find out the electric field. This point, that this point is O, OP is R. If I want to find out the electric field at here, due to this, I will have to place a unit coulomb charge, plus 1 coulomb charge here at P. Plus repel. Electric field will be in this direction. Okay. Consider a small area element ds. Okay. Consider a small area element vector ds. The area vector is always perpendicular to plane of area. It is perpendicular to area vector, direction of area vector. Is it okay? Here, the electric field makes an angle alpha with the n cap. Done. The small flux through this small area element, small electric flux through small area element ds is d phi is equal to E dot ds. E dot ds. D phi will be equal to E ds cos of angle between E and ds. Here angle between E and ds is alpha. E ds cos of alpha. So simple. And let we name this equation as 1. Let if I want to find out the total flux of the closed surface, then I will divide this closed surface into infinite number of small area elements ds, 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 ds. Okay, and we will get the electric flux d phi, 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 d phi. And if I want to find the total electric flux, then I will do the integration. I mean, then I will make the sum of all d phi, summation. Okay, total electric flux. Okay, then I will make the sum of all d phi. Then I will get the total electric flux of this from this closed surface area. Sum of all d phi. It will be like this way: E ds cos of alpha. Understood? We know that due to point charge q at point r, similar thing, I plus 1 r t. Okay. If I want to find out the electric field due to given point charge, it will be kq by r square. K q by r square. Then this is the r, this is the q at point E. the value of E will be KQ by R square. I can put the value of here E K 1 by 4 pi epsilon naught Q by R square ds cos alpha. 1 by 4 by epsilon naught constant, Q charge constant. I can write the above equation in this way: Q 4 pi epsilon naught summation ds cos alpha divided by R square. Understood? Area ds, area divided by radius का square. It is a solid angle. It is the solid angle made by small area element ds at point O. That it is the d omega. Okay, area divided by square of r. It is a small solid angle made by the small area element at the point O. Phi is equal to Q by 4 pi epsilon naught into summation of d omega. Here summation of d omega, what it's be? That sum of all solid angle made by all ds, made by like this way here, by all closed surface 3D. Sum of all solid angle made by all ds at O. Understood? Then Q is equal to phi is equal to Q by 4 pi epsilon naught into the total, it means that total solid angle made by the total surface area at the center. It will be 4 pi. Okay, it is cancelled by this. Then phi is equal to Q by epsilon naught. Done. That is Gauss law. Hence, it is proved. Is it okay? This was the today topic. In the next lecture, we will do the further explanation or further deep concepts or the applications of the Gauss law. Okay, thank you.